Good day, everybody. How are you all doing? Hope you are doing great today. It's bright and sunny outside today here. I hope you're doing great today so we can start talking something new. Okay. So far, we have been talking about how to display qualitative data, categorical data without any numbers. Now is the time we get started talking about how to deal and display, how to deal with and display numbers, numerical information, not qualitative information anymore, quantitative information. How do I display those? So before I get started, I'd like to remind you of my channel. Please subscribe to my channel. I have, lectured on lots of areas in statistics and I've solved other kinds of problems just for you. So please subscribe to my channel by hitting the red subscribe button at the bottom right corner. At the same time, please click on the bell button because that way you will be notified every time I upload a new video. And please do not quit. You will learn a lot if you please stick around till the entire presentation. It will not be long. I assure you, it will not be long. It will not be boring. So please stick around for the whole presentation. I appreciate that, and I appreciate if you please subscribe to my channel. So without further ado, let's get started. Okay, so as I told you, so far we have been dealing with qualitative, categorical data. Now we are going to deal with quantitative data or numerical information. And the method that we will use or discuss about today is stem and list. Okay. That's one way of displaying numerical data or representing the data in figures. So here it is. Stem and leaf displays an effective and compact way to summarize data. This is the key, the second bullet. Each number in the data set is broken into two pieces. That is the critical thing, referred to as the stem and the leaf. The stem is the first part of the number and consists of beginning digits. The leaf is the last part of number and consists of the final digit. So one way to think of it is the leaf is the last part of the number or the last digit and the stems are the numbers before it. So leaf, usually it's in the ones place. Okay, that's the number in the ones place is the leaf. Numbers before it are the stems. That can be tens, hundreds, thousands. At the bottom line, the leaf is represented usually the number in the extreme right place or in the ones place. Okay, and then on the left you have tens, hundreds, thousands, and those are the stems. So here is an example. Okay, so they're looking at dirty money. Okay, so the gem scores with higher scores corresponding to dirtier surface for 27 bills of various denominations ranging from $1 to $100. So as you can see, all these numbers are in three digits. Take a look at the first row of the numbers. First row, the first number, the starting point is 032. Actually, the number consists of two digit 32, and we placed a 0 in front of the 3 to make it a three digit number from 2. Why did we do that? Because if you look at the bottommost row or the lowest row, you will find the last entry in that row is 633, three digits. So to make everything in three digits, the two digits number in the first row, we have added a 0 in front of the number. Now, as I told you, usually the leaf is the number in the ones place. For example, for 032, 2 will be the leaf and the stems are the numbers before that, 0 and 3. So let's take a look at how they have done. Stems are the numbers in the left of the vertical column. Like I said, 0 is the stem, 1 is the next stem. Leaf numbers in the right of the vertical column. Here, the stems are in the single digits, the numbers in the hundred places. Remember, the highest number is 633. So 6 is the highest number in the stem, 33 is the corresponding numbers in the leaves. So each number in the leaves here consists of two digits, the number in the ones place, number in the tens place. For numbers which are originally two digits, like 32, we made it a three-digit number by putting a 0 in front of the 3, and the 0 became the stem. The remaining two digits became the leaf. Okay. So numbers in the right of the vertical column is the leaf. Legend stems are in the hundredths place, as I said. Stems of the numbers on the left of the vertical line, they are in the hundredths place. For 32, 0 is the stem, 32 are the leaves. Okay. So the observation has a stem of 0 and a leaf of 32 corresponding to a germ score of 0.32. Figure 3.1 suggests a typical or representative germ score in the stem 1 and row maybe around 119. Okay, maybe around 119 because that number is repeated. As you can see, the stems with 0 and 1. 0 in the hundreds place and 1 in the hundred place, those two stems have the maximum number of leaves. So the center of these numbers will be in those two sections, in those two stems, 0 and 1. The gem scores are mostly concentrated from 32 to 273 range, but there are two values that stand out on the high end that are far removed from the rest of the data, 609 and 633. That is, these two numbers, 609 and 633, will have stem of 6 and the leaves of 09 and 33. Okay, so if we go back, look at the class with the stem of 6 on the left of the vertical line and leaves 09 and 0 and 33. Those are the two numbers, 609, 633. Why do they stand out? Because those are the highest germ score, germs on the surface of a dime, nickel, quarter, or on a dollar bill. High germs. Okay. So what do these germ scores mean? For reference, it is recommended that a food establishment surface should have a germ score of 10 or less. The average germ score for other surfaces studied were 68 for New York City subway pole, 163 for bathrooms at Penn Station in New York City, and 664 for door handlers at McDonald's. Door handlers at McDonald's. Okay. What is an outlier? As the name implies, outlier. It is a number which is far away from the rest of the data. Okay. So here they go through some rules of when to use stem and leaf displays, etc. Okay, so when to use numerical data set with a small to moderate number of observations does not work very well with large data sets, and how to construct. So select one or more leading digits for the stem. That's on the left of the vertical line. The trailing digits are sometimes just the first one of the trailing digits become the leaves. List possible stem values in a vertical column. Record the leaf for every observation beside the corresponding stem value. Indicate the units for stems and leaves in the display. So we talked about outliers already. Okay, what to look for? We will look for a representative or typical value in the data set, extent of variability. Again, what is variability? Numbers are all over the place. Variability, an easy measure of variability in the data is the maximum value in the data set minus the minimum value in the data set. That gives you a range of numbers, okay? So we will look for presence of gaps and outliers, numbers which are far away from the rest, extent of symmetry. Okay, where there's a perfect center and the one below the center and one above the center to the look the similar number and location of peaks. Okay. Natural choice of stems maybe may result in too many observations. So if you have a stem of two and there are too many leaves, then it becomes looks the diagram looks too crowded. Okay, so how do you break that up? Divide leaves at each stem into two groups: low starting with 0 to 4 and high starting with 5 to 9. So look at this data. Data on a seat belt used for each of the 50 United States states and the District of Columbia are from this study. So look at the numbers, okay? The first row starts with 95.7. Of course, that is not the lowest. There are numbers far lower than 95.7. For example, right now I can see on the third row or the fourth row. If you go to the fourth horizontal row, you will see there is a number 68.9. Okay, so observations of percentage of drivers using seat belts. So one state has 68.9% of the drivers using seat belts. And that looks like that looks like the lowest. And if you're looking for the highest percentage in the first row, top row, you have numbers like 97.3. That's really good. That means 97.3% of the drivers in that particular state are using seat belts. So, if we had taken a stem, so first off, we will remove the number after the decimal. So, for example, 95.7, which is the first entry in this table, will become 95. 88.4 becomes 88. 87.2 becomes 87. Why are we removing the digit after the decimal? Just to mm, so that we can make the numbers look simple so that we can do a decent stem and leaf display. Okay. So if you look at the bottom, figure 3.17 on the right, stems of 6 means the first number is 68. And then you look at the 9 stem and so many leaves in that stem of 9. That figure 317 looks very crowded because in the 7, 8 and 9 stem there are too many leaves. So what do you do? How to get rid of the crowding? You divide each of them into lows and highs, each stem into lows and highs. So 6 low would have been from 0 to 4, that is from 60 to 64. 6 high is from 65 to 69. Fortunately, we have only one entry in 6 high, which is 68. Then 7 and low from 0 to 4. I'm now looking at 3.18, the one diagram on the top. 7 high is from 7.5 to 7.9. We do not have any 75. Our lowest in 7 high is 76. That number 6 means 7 in the stem and 6 in the leaf. It is 76. Similarly, the number 7 and 8 means 78. 7 in the stem, 8 in the leaf, and so forth. So as you can see, the advantage of dividing each of these stems into a low and a high, remove the crowding from figure 317, looks more neat and clean, and you can see the class with a stem of 9 low, that is from 90 to 94, has the highest number of entry, and the one above it or one just above it is 8 high from 85 to 89. That has also got a lot of leaves. So we will focus our attention on these two classes, 8 high and 9 low, because that's where most of the leaves are. That's where the center of the data will fall. But at the same time, we should pay attention to 6 high and 868. That's an outlier far away from the rest. Okay. So you have been wondering, is that the only use of stem and leaf? No, there is another use of stem and leaf, and that is I will explain to you in a minute. So again, stem and leaf is for a small set of data, okay, not too complicated, where usually the rightmost digit or the one in, if the number is in the ones position, becomes the leaves. The number in the tens position for a two-digit number becomes a stem. The leaf is usually the rightmost digit. The stem is usually the leftmost digit in case of two-digit number. What do we do with three-digit numbers? Well, we can have two digits in the stem, and the rightmost digit in the ones place can become leaf. So that's for a single set of data. How about if we have two sets of data? Okay, then we do a comparative stem and leaf data. So here is an example. Progress for children included the accompanying data on percentage of primary school age children who were enrolled in school for 19 countries in North America, Africa, and 23 countries in Central Africa. So again, we can forget the number after the decimal. Why do we do that? Again, to remind you, we do that so that the numbers look simple and easy to do in a represent in a stem and leaf plot. So for example, 54.6 will become 54, and the last number 86.6 will become 86. Forget the number after the decimal, and then you do a side by side stem and leaf. Remember, take a look at the data Northern Africa. The lowest is 54.6, which can have a stem of 5 and a leaf of 4. What is the highest? So 54.6 is falls in 54. Round it down to 54. We neglect the number after the after the decimal place. Point 6 is neglected, it becomes 54, but this is stem of 5, leaf of 4, that is a 5 low. Remember, 5 low is from 0 to 4 leaf. Okay, next there is a number 34.3. That's a 3 low tooth because we're ignoring the 3 after the decimal. 34, 3 stem, 4 leaf, and so forth. Okay. Similarly, if you look in Central Africa, the lowest, I believe, let's take a quick look, is 34.6. A stem of 3, leaf of 3 low, because it is 34. Okay. So we can have the stems in the center and the leaves for one set of data on the left, one set of data on the left. Remember, the stem is in the center for one set of data, the leaf is in the left for another set of data, second set of data, the leaf is in the right, as you will see. Well, they did not divide it into three low, three high, or four low, four high. They just kept stems of three, four. Remember, on the left you have Central Africa data, on the right you have Northern Africa data. Leaves for Northern Africa in the left, or I'm sorry, leaves for Northern Africa are on the right of the second vertical line, and leaves for the Central Africa are on the left of the first vertical line. The stems are in the middle. The stems had not been divided into three low, three high, four low, four high, so forth. Only 3, 4, 5, 6, 7, 8, and 9. Okay, and remember, the numbers after the decimal places have been ignored. Okay, so for Northern Africa, the lowest is 34. Similarly, for Central Africa, the lowest is 34 too. But you look at the distribution of leaves in each of these areas, Central Africa and Northern Africa, you will see a lot of leaves in the stem of 9 for the Northern Africa. For example, in Northern Africa, with a stem of 9, it starts from 97, goes as high. Actually, it starts from 92 and goes as high as 98. With the same stem of 9, look at Central Africa. 97 and 98. So what do we see? Immediately we see that there is a lot of leaves in stems of 8 and 9 in northern Africa, indicating that higher percentage of school-age children go to school in northern Africa, not so in Central Africa. Okay. From the comparative stem and leaf display, you can see that there is quite a bit of variability in the percentage enrolled in school for both northern and central African countries, and that the shapes of two data distribution are quite different. The percentage enrolled in schools tend to be higher in northern African countries than in central African countries. Okay. Uh, Although the smallest value in each of the two data set is about the same. For Northern African countries, the distribution of values has a single peak in the 90s, with the number of observations declining as you move towards the stems corresponding to lower percentages enrolled in school. For Central African countries, the distribution is more symmetric with a typical value in the mid 60s. So, take a look again. Look at Northern Africa on the right, the leaves on the right of the second vertical line. Okay, look at the stem of 9 at the bottom. In Northern Africa, there are a lot of leaves with that stem. In Central Africa, it is not so. In Central Africa, the stem, which has the highest number of leaves, is 6. Okay, so that is the class where you can expect the mean, the center of the data, mean will fall. Okay, so quite a bit of spread in both the countries, in both the areas, I should say. Northern Africa, lowest is 34, so is it in Central Africa. In Central Africa, 98 is the highest. In North Africa is also 98. But the number of leaves in each classes are quite different. For example, in the class with stem of 6, Central Africa has got 1, 2, 3, 4, 5, 6, 7 leaves, nothing in Northern Africa. So, from the distribution of leaves, we can easily conclude the higher percentage of school-age children go to school in Northern Africa. So, here I clearly show you the advantage of using a comparative stem and leaf. That means stem in the center and leaves for two groups of data on two sides of the stem. One on the right side, one on the left side. What is the advantage? Compare and contrast. Okay. I'll stop here today. If you have any question, you can always, write me a note. And please give me a thumbs up if you really like my video. And I'm also curious where you are watching my video from. So please drop me a note on that. And please give me thumbs up if you really like me a video. And please let me know where are you watching from? What else you want to know? Are these videos any good? Drop a comment. I'll appreciate that. Okay. And please do not forget to watch me tomorrow when I'll be back with another new presentation. And if you like this video, share with your friends and please subscribe to my channel by hitting the red subscribe button at the bottom right corner, right? Bottom right corner. And please do not forget to click on the bell button, which will send you a notification every time I upload a new video. Thanks for watching. Take care. Have a nice day. I will see you tomorrow. Definitely. Take care.